Arrow functions are a modern addition to JavaScript, providing a more concise way to write function expressions. They help maintain lexical this binding and improve code readability. Let's see how they compare to traditional functions. Here's a traditional function which adds two numbers, a and b, and returns their sum. Here is the equivalent arrow function. It uses the equals syntax, also returning the sum of a and b. Finally, a more concise arrow function, where if the function body is just a single return statement, we can omit the curly braces and the return keyword altogether. All three functions achieve the same result of adding two numbers. Arrow functions offer flexibility in how they handle parameters. If there are no parameters, you must use empty parentheses. For a single parameter, you can omit the parentheses. When using multiple parameters, they must be enclosed in parentheses. Default parameters are also supported, allowing you to set fallback values. Rest parameters, indicated by 3 dots, let you pass a variable number of arguments. Lastly, destructuring in parameters works as well, enabling you to extract values directly from objects or arrays. Here is an example of each of these cases. This first function, greet, has no parameters, and it returns the string hello. The next one, named double, takes a single parameter x and returns x multiplied by 2. The third function, add, takes two parameters, x and y, and returns their sum. The function, greetUser, shows default parameters with the default name of guest that can be overridden by passing an argument. Finally, the sum function uses rest parameters and the reduce method to add an arbitrary number of numbers. Arrow functions support both implicit and explicit returns, making them versatile for different situations. An implicit return is when the function body is a single expression and does not need curly braces or the return keyword. This expression's value is returned automatically. If an object literal is to be returned, it should be enclosed in parentheses. Here is an example. The double function returns x multiplied by 2 implicitly. The getUser function returns an object, where we have enclosed the object in parentheses. Array mapping is another great use case for implicit returns. Explicit returns are used when the function body contains multiple lines or needs more complex logic. Here is an example. The getTotal function calculates the total amount with tax, and then returns it explicitly. The function getStatus uses conditional logic, explicitly returning a string based on the code passed. Arrow functions work seamlessly with object literals and destructuring, providing concise ways to create objects and extract values. When returning an object literal, you must enclose the object in parentheses. Here, the makeUser function returns an object with properties for name, age, and a created timestamp. Computed properties within object literals are also supported. The function getProp returns an object with a method where the method name is computed dynamically based on the input. Destructuring in parameters allows you to extract values directly from objects or arrays. Here's an example. The function formatUser extracts the name, age, and email from the object passed to it. Array destructuring is also supported, enabling you to pick the required parameters in order. The function getFirstLast picks the first and last item in the array while skipping the second item. Finally, you can provide default values during destructuring. The function greet uses a default value guessed if the name property is not supplied in the arguments. A key difference between regular functions and arrow functions lies in how they handle this binding. Unlike regular functions, arrow functions do not have their own this value. Instead, they inherit this from the enclosing scope. Let us look at an example using the setTimeout function. In a regular function inside the setTimeout function, the this refers to the global context or is undefined. So the output of this .name will be undefined. In the equivalent example using arrow functions, the inner anonymous function passed to the setTimeout function inherits the this from the surrounding scope. This makes it easier to refer to the properties of the object within the timeout callback. With this .name, outputting John. There are some key differences between regular functions and arrow functions, making each suitable for different use cases. Regular functions have their own this binding, which can be useful but also tricky to manage, particularly in callbacks. They can also be used as constructors, using the new keyword, and have an arguments object, which contains all the arguments passed to the function. Regular functions can use the yield keyword in generators, and they can be named or anonymous. On the other hand, arrow functions inherit the this value from their parent scope. This makes it easier to refer to the properties of the object. Arrow functions cannot be used as constructors, and they do not have the arguments object. To capture REST parameters, the syntax must be used. They can't be used as generators, and they're always anonymous by default. Arrow functions shine in various use cases, particularly with array methods and promise chains. When using array methods like map, filter, and reduce, arrow functions provide concise syntax for transformations and filtering. Here, map doubles each number, and then filter and map are chained together to get names of all users with age greater than 25. For promise chains, arrow functions allow you to write asynchronous code in a clear and readable way. Here's an example showing how to fetch data, convert the response to JSON, filter it, and then log it to the console using arrow functions. Arrow functions are also very useful in event handling, particularly within components of frameworks such as React. In a React component, arrow functions provide a concise way of creating event handlers. Here is an example where the handleClick function uses the setCount function to increment the value by 1. Finally, arrow functions are excellent for creating chains of operations. Here is a code example which shows how we can create add tax, add shipping, and discount functions to calculate a total price. The functions are composed using the reduce function. It is important to understand the limitations of arrow functions in order to use them appropriately. Arrow functions should not be used as methods and objects, as they lose the object context and this will be undefined. The correct approach is to use the regular function syntax for object methods. Another common mistake is using arrow functions as DOM event handlers. The this value is not what we expect. So it is best to use regular function syntax for such use cases where access to the element is needed, using event.target in this case. Using this keyword will be incorrect. When using arrow functions, it is important to follow some best practices for cleaner and more maintainable code. Keeping the functions simple by using implicit returns for single expressions greatly improves code readability. When returning an object literal, ensure that the object is enclosed in parentheses. Writing functions which perform a single task and can be composed together is also a good practice. Here is an example of composing normalize and validate email functions. Arrow functions can be used to create function factories and higher order functions. Here is an example. The createValidator function returns functions which perform some form of validation using regular expressions. This approach leads to cleaner, reusable code by creating functions such as isEmail and isPhone that can be used in other parts of the code. Arrow functions are a great choice when working with asynchronous operations, making your callbacks readable. Here is an example showing the use of async and await with arrow functions to fetch data from an API. Arrow functions can be used in combination with other functional programming constructs to create elegant solutions. Here we are creating a function composition utility called pipe. It takes multiple functions and returns a function that runs the input through these functions sequentially. This can be used to create specialized functions such as add tax, add shipping, and add discount, and combine them to create a price calculator. As a summary, arrow functions provide a concise syntax for functional programming. The lexical this binding greatly simplifies the management of callbacks. They are perfect for array methods, promise chains, function composition, and creating utilities. You should avoid using arrow functions for object methods and constructors. They are also great to use with React's functional components. With these concepts in mind, you are well on your way to mastering the use of arrow functions in JavaScript. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.